I think there was one similar to this in the first review, but let's go ahead and do this one. We've got an equation. We've got both sides. If there is more than one solution, separate them with commas. So there could be two solutions. Notice we have two parabolas, and they're both going to open upwards. Again, if you think through this, so there could be two places where they intersect. Could be one place. We'll see. So what we're first going to do is get them both as a quadratic equation. So we need to take this one and FOIL it out, right? This is v plus 6 times v plus 6. So we're going to FOIL. V times v is v squared. V times 6 is 6v. 6 times v is 6v. And then 6 times 6 is 36. Okay. So we're going to write that here as v squared. 6 plus 6 is 12 plus 36. Okay, so we've simplified that a bit. And then we're going to come with what's on the other side, this side over here. We've got 2v squared plus 21v plus 50. And the idea is whenever we have a quadratic equation, we want to get everything to one side and 0 on the other. So which one looks better? Well, we got 2 here and 1 here. So if we subtract 1, so we go in this direction, move all of this left side stuff to the right side and get 0 here, we will be good. So we're going to subtract v squared. We're going to subtract 12v, and we're going to subtract 36 because we want this whole side to be 0. Whatever we do to one side, we do to the other. Minus v squared minus 12v minus 36. Red. On this side, cancel. Plus and minus are going to become 0. Plus and minus are going to become 0. So we have 0 on this side. Over here, 2 minus 1 is going to give us 1v squared, or just v squared, right? 1v. Positive. 21 minus 12 is going to give us a plus, that's 8, 9. 8 gets us to 20, 1 more gets us to 9. And then 36 to 50, so 4 gets us to 40 plus that 10, so that's got to be 14. 40, yeah, that should do it. Now, we can do this in one of two ways. We could graph this and find where it crosses the x-axis. We'll do that as our check. I'll do it afterwards. If you want to do it first, fast forward to that and take a look at how to do that. Otherwise, we can factor. So two modes. If factoring is difficult for you, you do the graphical way. That's the thing about math. There's more than one way. So let's go ahead. Sometimes one will help us build the other. So we know, first of all, when we look over this for factoring, we've got an addition. So that means that both are going to be the same sign. We're looking for two numbers that multiply to 14, and then they add to give us 9. Well, what's 14? It's 1 times 14 is 14, but if I add those, I get 15, right? So 1 times 14 is not very promising. That doesn't give me that. But 2 times 7 is also 14, and 2 plus 7 is 9. Those must be the numbers I need to use. So I'll give a 7 and a 2, and since there's V1, 1V and 1V, that should be good. This plus means they're the same sign, and since it's a plus 9, they're both going to be plus, addition. If it was a minus 9, they would both be negatives. Okay, so that's how we do that one. That's equal to 0. We use the product rule of 0. So whenever two numbers, and this is one number, this is the other number, they multiply to give us 0. One of them has to be 0. That's the only way to get 0 with multiplication. So v plus 7 equals 0, or v plus 2 equals 0, and then minus 7 from both sides. V equals minus 7, minus 1, watch, equals negative 7, minus 2 from both sides over here. So v equals negative 2. Those are our two answers. We look at our domain, and remember there is no division by 0. There's no square roots, so these numbers are going to work. Especially when we get to logarithms, you're going to want to remember to check your answers to make sure they work, or that they are within the domain. In this case, they both are. Um, Again, we're going to go to a graphical method, and we'll see how that works as well. But while we're here, let's go ahead and enter them. We just need to make sure to separate them by commas. It doesn't say they have to be in any particular order. So watch all the rules or the instructions that they give you, though. So what I'm going to do is I'm just going to graph this side here. And so, and again, I'll use x in the place of e because that's what the calculator does. So we come to y equals, we're going to put in x squared. So I use this one. You could use this key too, but I like, because if it's going to be cubed or something, I like using knowing where that exponent key is. 9x, oops, not like that. Come down, plus 9x, plus 14. We're going to go to the graph. I'm going to go to a zoom standard and kind of just hope that it shows up, and it does. And I see my -2 and 1, 2, 3, 4, 5, 6, 7, -7. I can also go, it's a real easy trick to go to my table, but remember my table, because I did something last time, is way out there. I got to go to my table set. Let's start it at 0. Or, oh, wait, well, I'm going to go start at 0. Let's see what happens. Now, I'll go to table, second table. What I'm looking for is where y is 0. And I can see y is getting bigger, not smaller. And this way, oh, there's one, -2, y is 0, so that's one of the answers. If I go, oh, there's the other one, right? And then if I go past this way, we're going up. And you could kind of see it from the graph. So comparing the graph and the numerical values, there's some negative stuff here. These are the two places we get 0. Just one more thing I could show you if you want to find, because sometimes what if this was like 7.2 or something? So second calc, to find the exact the values where they are, wherever they are, is we go to finding the zeros. And so it's looking for a left bound. It's telling me I'm at the 0.014, but I don't see it, but that's up there. So I'm going to come to the left. Again, which one do I want to find first? It doesn't matter, but I'm going to go find the furthest to the left. So I just keep, or I hold this down. There I am to the left of this point here that I want to find. So I'm going to hit enter. And then it wants me to get a boundary to the right. So I'm going to go to the right, hit enter. And it wants a guess, but since I'm here, if I just hit enter, it will guess, it will go between those two real quickly and find me that I've got a 0 at -7. Do the same thing again, second calc, find the 0. And this time my left bound is going to be down, if you think of it down here, but it's the x value is to the left of the point I'm looking for. Hit enter, there's the boundary. Get a right bound, so I got to get to the right of the x-intercept. Hit enter. I now see that the x-intercept is between these 2 points. I hit enter, and it gives me the -2. So you could do it graphically. You could do it either way. Okay, so that is our question number 6.